Hi, welcome to part 2. Today we're going to take a look at how we find the derivatives of inverse trig functions. Now we talked about in the previous one how we get our answers and why we have to restrict the domain. So for the cosines, we restrict it to quadrants 1 and quadrants 2. And that's because in quadrant 1, cosine is positive. And in quadrant 2, we know that the cosine is negative. So that's going to restrict our domains right there for us. Now, all the cosines follow this. Arc cosine, arc secant, and even arc cotangent, because this is cosine on top. So they're always going to be in quadrants 1 and 2 for the answers. Now, the sines are in quadrants 1 and quadrants 4. And that's what we discovered that we talked about in the last video. So over here, on top, sine is positive, and on the bottom, it's what happens if sine is negative. And these are for sine, cosecant, and tangent. Again, because here sine is on top. So let's kind of review some things here real quickly. So if I want to find the arc sine of 1, negative a half, well, what this is telling me is I want to get the angle. I want to get theta. Now, because it's arc, I'm only going to get one answer. And it's negative, so that's going to put me in quadrant 4. Now, sine is negative in quadrant 4, so it's down in here. So if I look down here, where's sine negative 1/2? Right over here, it's at the pi over 6. Now, because in quadrant 4, though, we make it negative pi over 6. So the answer here is negative pi over 6. And if we kind of figure out this chart here, remember we're going to go backwards. Negative pi over 2, negative pi over 3, negative pi over 4. Here's 0. We got pi over 6, pi over 6, pi over 4, pi over 3, pi over 2. So now I could have said, oh look, 11 pi over 6, and that would have been kind of technically right, but because we're talking about arcs, we want to keep in terms of a reference angle, so we make it negative pi over 6. So where is cosine negative root 2 over 2? Well, cosine, that's going to put me up here. So negative is going to put me in the second quadrant, and in this case right here, that's going to give us 3 pi over 4. Not going to be negative in this case because I'm not going backwards like here. Because I want to keep it, and I keep it negative also in terms of sign because I'm going from negative pi over 2 to pi over 2. Here we're going from 0 to pi. So we can keep them all positive. Now, if I want to use the calculator, very simple. Now the calculator is really good. It already just gives you one answer regardless. So let me get out of here real quick. Oops, enter. So I can just type this in. There's two ways I can do it. I can literally type in the phrase arctangent, or I can just use my trig button, inverse tangent. Now it says inverse, but it's only going to give us the one answer anyway. So I type in negative 0.3. We hit enter, and we get this negative 0.291. Very simple. The calculator is already going to give it to you in the correct form. All right, so let's go ahead and let's take a look at some evaluations here. Now, so if I want to evaluate the sine, just a quick review of trig because we can use it to help prove the derivative. This is right here. I want to find the sine of the arc cosine of 4/5. Well, this right here is just saying that the cosine of some angle is 4 over 5. So if I draw my right triangle, very simple, just from pre-calc, there's theta. Cosine adjacent over hypotenuse, that's going to make that 3. And now I want to find the sine of that angle, which is easy, 3 over 5. And there's our answer. Over here, so if I do it generically, sine of the arc cosine of x, we're saying that the cosine of some angle is x. So if I draw my right triangle, there's theta, x over 1. Here we get the square root of 1 minus x squared, Pythagorean theorem. I want to find the sine of that angle, which is the opposite, the square root of 1 minus x squared. And there's our answer. We can do the same thing for arctangent. Secant of the arctangent 3x. We're saying that the tangent of some angle is 3x. So if I draw my right triangle, tangent 3x over 1, we get the square root, using Pythagorean theorem, 1 plus 9x squared. I want the secant of that angle. So secant is the hypotenuse over the adjacent, so it's the square root of 1 plus 9x squared. And there we have those. Quick look at that. We just did a week's worth of pre-cal in like 2 minutes. But we can use these to kind of help us derive some problems, to help us using to derive the triangles to derive the derivative, which we'll take a look at right now. So we want to find the derivative of the arcsine of x. The problem is I don't know it. So I'm going to use inverses. I'm going to rewrite this as the sine of y equals x, because I know the derivative of sine. And using implicit differentiation, I can solve it. The derivative of sine, we get cosine of y, implicit dy dx equals 1. Solve for dy dx, we get 1 over the cosine of y. Now that's my derivative, but I want to put it in terms of x. Remember that we're not in terms of y, we're in terms of x. So I have to replace cosine of y. I can use this right here to do that. We know that the sine of y equals x. So if I draw my right triangle, remember that y is my angle, and sine is opposite over hypotenuse, just like we did up here. So this length right here is going to be 1 minus x squared. Well, I can now replace cosine of y. Cosine is the adjacent over hypotenuse, so it's just going to become 1 over the square root of 1 minus x squared. And there's our derivative. 1 over the square root of 1 minus, except we're going to call it u squared. Now, we're going to multiply by u prime. That's just remind us of chain rule right there. And there's our derivative. I can do the same thing with arctangent. Okay, so if I want to do the arctangent, switch them around. The tangent of y equals x. I know the derivative. Secant squared of y, dy dx equals 1. I could just solve it. Dy dx, we get 1 over secant squared of y. But again, I want it in terms of x. So we have to replace the secant squared of y. So we know that the tangent of y equals x. I know that, so I can use this. Draw my triangle. Tangent of y is my angle. Tangent is opposite over adjacent, so x over 1. And I get the square root of 1 plus x squared. So I can replace this. Now, be careful. Secant is a hypotenuse over adjacent. Don't worry about the adjacent, it's just 1. So I'm going to get this 1 plus x squared squared. And if you notice, the square roots cancel, and we're left with 1 over 1 plus u squared. Now, we're going to replace the x with u, and because of chain rule, we multiply by u prime. That's our chain rule. Okay, so don't forget that chain rule right there. We normally don't worry about that. I mean, I tell students, ignore that. Okay, you're not going to forget chain rule, hopefully. Alright, the next one we're going to take a look at, secant. And then we'll take a look at some examples in part 3. So let's prove arc secant here. Same idea. We're going to say the secant of y equals x. The derivative, secant y, tangent y, dy dx, because it's implicit, equals 1. So therefore, my derivative dy dx is going to equal 1 over the secant of y times the tangent of y. So I have to replace both of them this time. So I know that the secant of y equals x. Using my right triangle, there's y. Secant is hypotenuse over adjacent, so this is going to become the square root of x squared minus 1. So now when I replace it, the secant of y, well, we know that's going to be x. The tangent of y is the opposite over the adjacent. Again, that's over 1, so we don't worry about it. So we get the square root of x squared minus 1. Now there's a rule for us. This x right here must be positive. It's a radius. So therefore it has to be positive. So to make sure it stays positive, we use absolute value. So we 1 over the absolute value of x times the square root of x squared minus 1. So we use absolute values to make sure that's always going to be positive. So how do we get the arc secant? It's 1 over, and we're just going to write this as 1 over, and we get the absolute value of u times the square root of u squared minus 1, and don't forget u prime. Remember that u prime, that's just our chain rule. So let's talk about the rules, and then in part 3 we'll take a look at some examples. Arc sine, we really can say it's just 1 over the square root of 1 minus u squared times u prime. Arctangent, 1 over 1 plus u squared times u prime. In secant, we just found 1 over the absolute value of u times the square root of u squared minus 1 times u prime. Again, that u prime is chain rule. You don't have to write it. You're not going to forget chain rule, okay? So how do we get the arc cosine? Just change the signs. Negative 1 over the square root of 1 minus u squared times u prime. Negative 1 over 1 plus u squared times u prime. And arc cosecant, negative 1 over the absolute value of u times the square root of u squared minus 1 times u prime. And you can verify those by doing this process up here. So go to part 3, and we'll take a look at some examples down here, okay? See you then. Bye-bye.